Okay, let's go. Number 1. SGRA star. 26,000 light-years from Earth. At the exact center of the Milky Way, there is a supermassive black hole with a mass 4 million times that of the Sun. Astronomers call it Sagittarius A star. Today it is almost completely quiet, a sleeping giant by the standards of galactic nuclei, producing occasional X-ray flares that last a few hours and then fade. By the violent standards of what supermassive black holes are capable of, it is generating almost nothing. But in 2010, astrophysicists Meng Su, Tracy Slatier, and Douglas Finkbeiner at Harvard University published an analysis of data from the Fermi Gamma Ray Space Telescope that revealed what happens when it wakes up. Extending outward from the galactic center, both above and below the plane of the Milky Way, they found two enormous lobes of gamma ray emission. Each one stretches roughly 25,000 light-years from the center, giving the entire structure a span of 50,000 light-years, more than half the diameter of the galaxy itself. They are now called the Fermi bubbles, and they are among the largest coherent structures in the Milky Way. The energy required to create them is staggering, estimated at roughly 10 to the power of 55 ergs, the equivalent of detonating hundreds of millions of supernovae simultaneously. Something at the core of our galaxy released that much energy in a geological eye blink, and the bubbles it blew are still expanding into the halo of the Milky Way. Here is the detail that makes the case genuinely uncomfortable. The eruption happened between 1 and 4 million years ago. The midpoint of that estimate places it while Australopithecus was walking upright across the African savanna. Our direct ancestors were alive when the center of the galaxy was erupting with the luminosity of a quasar and blowing structures the size of star clusters into the void above and below the plane. Astronomer Joss Bland Hawthorne at the University of Sydney and his collaborators, in papers published in 2013 and 2019, found independent confirmation in an unexpected place. The Magellanic Stream, a ribbon of gas trailing the Magellanic Clouds 200,000 light-years away, shows ionization on the side facing the galactic center that no current source of radiation can explain. The model that fits requires SGR A* to have been 100 million times more luminous than today, firing a cone of ionizing radiation outward for perhaps 1 million years, then stopping. The timing matches the Fermi bubbles. The most natural interpretation is a single catastrophic awakening, and then a return to silence. SGR A* is quiet now. Its occasional flares last hours. The last time it was fully active, it reshaped the structure of the galaxy and was visible to any eye within 200,000 light-years. We do not know what woke it up. We do not know what stopped it. We do not know whether the conditions that triggered it have accumulated again in the 4 million years since. It sits at the center of the galaxy we live in, as it has for billions of years, and it is waiting for whatever comes next. Number 2. The Dipole Repeller. In 2017, a team led by Yehuda Hoffman at the Hebrew University of Jerusalem published a paper in the journal Nature Astronomy that reframed our motion through the universe in a way that is genuinely unnerving. For decades, astronomers had known that the Milky Way and its neighbors are moving at more than 1 million miles per hour relative to the background glow of the early universe, and the working assumption was that we were being pulled, drawn by the gravity of distant, massive concentrations of galaxies like the Great Attractor, and, beyond it, the immense Shapley supercluster. Hoffman's team built a detailed 3-dimensional map of how thousands of galaxies flow, a map of the currents of the local universe, and they found that a pull was only half the story. We are being pushed too. The map revealed a vast region on the opposite side of the sky from Shapley, a region defined not by what fills it, but by what does not. It is a great emptiness, an enormous underdense zone with far fewer galaxies than average, and its effect on us is the mirror image of a mass. Because gravity is only ever attractive, an underdense region pulls less than the fuller regions around it, and the net result is that everything is drawn away from the emptiness, as though it were repelling us. Hoffman's team named it the Dipole Repeller. Our galaxy sits between two influences, pulled forward by the dense Shapley supercluster on one side, and pushed from behind by this vast void on the other, and the two effects add together, driving us along at over 1 million miles per hour toward a destination we did not choose. Here is the detail that makes the repeller stranger than any single massive object. The thing pushing us is, in the most literal sense, a nothing. It is not a structure we could image, not a cluster we could catalog, not an object with a surface or an edge or a light. It is an absence, a region of the universe emptier than it should be, and it steers the motion of our entire galaxy by the sheer fact of not being there. We are being herded through the cosmos by a hole, and because it is defined by emptiness, mapping it is uniquely hard. You cannot photograph a void directly. You can only infer its shape and depth from the way everything around it, and everything caught between it and the far superclusters, is set into motion. None of this is fringe science. The push and pull picture is now a standard part of how cosmologists describe our local motion, refined in later flow maps, and the general result has held up. What remains genuinely open is the full inventory of what lies in that empty direction, how deep the void truly runs, and whether the simple picture of two opposing influences fully captures the forces at work on the local group. The measurements are real. The completeness of the map is not. So our address in the universe is not a fixed point but a trajectory, and the trajectory was set for us. On one side, the densest collection of galaxies in our region, pulling. On the other, a great emptiness, pushing. We ride the seam between them at a speed no human machine will ever match, carried toward a place we have never seen, by a pull we cannot fully account for, and a push that is made of nothing at all. Number 3. The cold spot. In 2004, analyzing the first detailed full-sky maps from NASA's WMAP satellite, cosmologists found a flaw in the oldest light in existence. The cosmic microwave background is the radiation left over from the moment the universe first became transparent, about 380,000 years after the Big Bang, and it is astonishingly smooth, the same temperature in every direction to within 100,000th of a degree. Those tiny variations are the seeds from which every galaxy later grew, and they are supposed to be randomly scattered across the sky. In the constellation Eridanus, they found a region that broke the pattern. A patch of the sky, spanning several degrees, was colder than it had any statistical right to be, a cold spot far larger and far deeper than the random fluctuations around it. When the Planck satellite mapped the same sky years later with greater precision, the cold spot was still there. It was not an error in the instrument. The first and most reasonable explanation was a trick of the light. If an enormous, unusually empty region of space, a supervoid, sat between us and that patch of the early universe, the light crossing it would lose a small amount of energy on the way, arriving slightly cooler, a cold shadow cast by a great emptiness. In 2015, a team led by Istvan Sapudi at the University of Hawaii reported evidence for exactly such a structure in that direction, a supervoid, perhaps 1.8 billion light-years across, one of the largest underdense regions ever identified, centered roughly in front of the cold spot. For a while it looked as though the anomaly had been solved by an unremarkable, if gigantic, hole in the distribution of galaxies. Here is the detail that keeps the case from closing. When cosmologists ran the numbers, the supervoid, even at its enormous size, could account for only a fraction of the cooling. The energy a void of that scale steals from passing light is not enough to fully explain how cold the cold spot is. The shadow is deeper than the object supposedly casting it, and into that gap between explanation and observation, a far stranger hypothesis was proposed and has never been fully excluded. Some theorists suggested the cold spot could be a bruise, the mark left on our universe by a collision with another universe entirely, a neighboring bubble in a vastly larger multiverse, pressing against ours in the first instance of existence and leaving a cold imprint we can still read in the oldest light. That idea sits at the outer edge of respectable physics, and no serious cosmologist claims it is established. Most expect that better measurements and a fuller accounting of the void will eventually bring the numbers into line without invoking other universes. But the honest state of the field is that the cold spot is not fully explained. The leading natural mechanism falls short of the observation. The exotic alternative cannot be tested with any instrument now imaginable, because it concerns a contact with something outside our own reality, before our universe had grown to a size that any telescope could survey. So the mark remains in the sky, in the oldest photograph the universe permits, a patch of cold that our best explanation cannot fully account for. Whatever pressed it there, a void too weak to be the whole answer, or something on the far side of everything, left its shape in the light, and the light has carried that shape for nearly 14 billion years. Number 4. The COB excess. In 2022, a team led by Todd Lauer at the National Optical Astronomy Observatory and Mark Postman at the Space Telescope Science Institute published a paper in the Astrophysical Journal that posed a question the field is still sitting with. They had been using the cameras aboard New Horizons, the spacecraft that flew past Pluto in 2015 and is now more than 5 billion miles from Earth, far out into the region where the sun is just another bright star, and the zodiacal light that fills our inner solar system has faded entirely away. From that vantage, with most of the optical interference of our own solar system stripped out, they tried to measure the true background brightness of the universe, the faint glow left by all the stars and galaxies that have ever shone. What they found did not add up. The universe, as seen from New Horizons, is roughly twice as bright as all known stars, galaxies, and other identified sources of light can account for. Not slightly brighter. Twice. The excess is not concentrated in any direction. It is not a point source or a cluster. It is diffuse and uniform, a glow that fills every part of the sky equally, coming from everywhere and nowhere at once, present in every direction the cameras were pointed. When you subtract every star, every galaxy, every known diffuse source from the measured brightness of the sky, you are left with a residual that the known universe cannot explain. Here is the detail that astronomers find uncomfortable to sit with. The most charitable interpretation is a vast, unresolved population of extremely faint and distant galaxies, just below the detection threshold of every survey ever conducted, contributing enough combined light to fill the gap. This is possible. It has not been demonstrated. A second explanation is intra-halo light, the faint glow of stars stripped from their galaxies during mergers and now drifting in the gravitational wells between clusters. The numbers for this fall short. It accounts for some of the excess, not all of it. The third possibility is the one no team has been willing to print as a conclusion, though the logic forces it to remain on the table. There is light in the universe, distributed evenly across the whole sky, that does not correspond to any identified source. Something is glowing. We do not know what it is. We do not know where it is. We cannot point at it, because it is not in any one direction. It is simply in the dark, all around, producing light that our most remote and most carefully calibrated instrument cannot account for. The Hubble Space Telescope measurement of the same quantity is lower, which may indicate a systematic error in one dataset, or may indicate that the source varies across different regions of the sky. The two measurements are in genuine tension. The result from New Horizons has survived repeated scrutiny. In the meantime, the sky is brighter than it should be, and the excess belongs to nothing we have found. Something in the dark is producing that light. We are inside it, surrounded by it, and we cannot say what it is. Number 5. The dark flow. In 2008, astrophysicist Alexander Kashlinsky at NASA's Goddard Space Flight Center published a result that a number of his colleagues found difficult to accept, and some still do. Working with the cosmic microwave background, the faint afterglow of heat left over from the Big Bang that fills the entire sky, he and his team measured the motion of hundreds of distant galaxy clusters. What they reported was that these clusters, spread across enormous stretches of the universe, were not moving randomly. They were all drifting in the same direction, coherently, toward a single narrow region of the sky, at a speed of hundreds of miles per second. He called the phenomenon dark flow. The reason the claim was so unwelcome comes down to what is supposed to be able to cause motion in the first place. Within our universe, things move because other things pull them, mass attracting mass. But the standard model of cosmology says that on the very largest scales the distribution of matter should even out, and the net pull in any one direction should fade toward nothing. There is not supposed to be a single mass concentration inside the observable universe, large enough and lopsided enough to drag hundreds of clusters, across billions of light-years, all the same way, and yet the measurement pointed to exactly that kind of coherent streaming, in a direction, at a speed, that nothing inside our horizon appeared able to produce. Here is the detail that makes dark flow different from everything else on this list. If the pull is not coming from inside the observable universe, then it is coming from outside it, from beyond the horizon that light has had time to cross since the beginning. The observable universe is not all there is. It is only the sphere close enough for light to have reached us in the roughly 14 billion years available. Whatever lies past that boundary is, in the most literal sense the word allows, invisible to us, not merely dark but causally cut off, forever beyond any instrument we could ever build. Kashlinsky's proposal was that dark flow is the gravitational tug of enormous structures out there, past the edge, imprinted on our universe from before it inflated to its current size, still pulling on everything we can see towards something we never can. The result has been fiercely contested. Later analyses of newer, more precise maps of the cosmic microwave background, especially from the Planck satellite, found weaker or absent signals and argued that dark flow may be an artifact of the measurement rather than a real bulk motion. Kashlinsky and his collaborators have maintained the detection through successive datasets and continue to defend it. There is no consensus. The disagreement is not settled by any observation currently available, and it may not be settled by any observation available for a very long time, because the one thing everyone agrees on is that if the source is real, it sits where no telescope can ever point. So the question hangs, unresolved, at the outer limit of what physics permits us to ask. Either a subtle error is hiding in some of the most careful measurements ever made, or a great many galaxies, ours in their company, are being drawn towards something that exists outside the entire visible universe, a pull with no possible image, from a place we are structurally forbidden to see. Number 6. PSOJ 318.522. In 2013, astronomer Michael Liu at the University of Hawaii announced the direct image of a world that should not have been where he found it. Catalogued as PSOJ 318.522, it lies about 80 light-years away, weighs roughly 6 times as much as Jupiter, and belongs to no star at all, drifting alone through interstellar space, warmed by nothing but the fading heat of its own birth. It was among the first free-floating planets ever imaged directly, and it put a single face on a statistic that had surfaced 2 years before, when a gravitational microlensing survey led by Takahiro Sumi at Osaka University, published in the journal Nature, found that these starless worlds are not rare exceptions. They are everywhere. The survey implied there could be as many Jupiter-mass rogue planets wandering the Milky Way as there are stars, and later work pushed the count of smaller, Earth-scale wanderers far higher still. The picture this forces is difficult to hold. For most of human history, the imagination placed life on worlds warmed by a sun, lit by a day and a night, anchored in a tidy system. That picture is a minority case. The galaxy is full of planets that were flung out of their birth systems during the violent early gravitational chaos of formation, hurled into interstellar space, and are now falling through the dark, cold on their surfaces, lit by nothing. They carry no daylight. They reflect no starlight to betray them. And there may be billions upon billions of them between here and the galactic center, an entire population of worlds that no telescope has ever imaged because there is nothing shining on them to see. Here is the detail that planetary scientists find uncomfortable to sit with. Cold and dark on the outside does not mean dead on the inside. A rogue planet keeps the heat of its own formation for a very long time, and a large enough world can hold a thick atmosphere or a deep shell of ice over a liquid ocean, warmed from below by radioactive decay in its core, exactly the way the buried oceans of Europa and Enceladus are kept liquid in our own solar system without any help from the sun. On a wandering world, that ocean could persist for billions of years, sealed beneath miles of ice, insulated from the cold of space, utterly independent of any star. Life that began in such a place would never require sunlight. It would never see a sky. It would evolve in permanent darkness, under pressure, around the chemical heat of its own planet, and it would have no reason and no way to know that stars exist at all. There is no evidence that any rogue world is inhabited. There is also no way, with current instruments, to check most of them, because they are dark by nature, and we find them only in the rare instant one drifts precisely in front of a background star. The forthcoming Nancy Grace Roman Space Telescope is expected to detect hundreds of these wanderers by microlensing, finally putting real numbers to the population. It will count them. It will not be able to look inside them. So they drift, uncounted and unlit, a swarm of buried oceans moving through interstellar space. If anything is alive down there, in the dark under the ice, it did not evolve to need us, or the sun, or light of any kind. It has been in the dark the entire time, and the dark is where it belongs. Number 7. The Galactic Center Excess. In 2009, physicists Lisa Goodenough and Dan Hooper at the Fermi National Accelerator Laboratory in Illinois published an analysis of data from the Fermi Large Area Telescope, a space observatory designed to map the sky in gamma rays, the most energetic form of light in the universe. They were studying the center of the Milky Way, roughly 25,000 light-years away, where the supermassive black hole known as Sagittarius A star sits surrounded by one of the densest concentrations of matter in the galaxy, and they found something the model did not predict. Gamma rays were flooding out of the galactic center at energies of 1 to 3 billion electron volts, in quantities that exceeded everything known sources in that region could produce, distributed in a spherical pattern around the core, as though whatever was making them was spread through a three-dimensional ball centered on the black hole. The energy range matters precisely. Gamma rays at 1 to 3 GeV are the predicted output of a specific theoretical process, the mutual annihilation of dark matter particles called WIMPs, weakly interacting massive particles colliding and destroying each other in the dense gravitational environment at the galactic center, converting their mass into pairs of gamma rays. This is exactly what dark matter annihilation is supposed to look like, and for more than a decade the galactic center excess has been the single most debated potential signal of dark matter detection in all of particle astrophysics. The shape, the spectrum, the spatial distribution, all of it sits uncomfortably close to what the models predict. Here is the detail that makes the case so difficult to close. The excess is also consistent with a large, hidden population of millisecond pulsars, rapidly spinning neutron stars that are among the most energetic natural objects in the universe and that produce gamma rays in exactly this energy range. If thousands of them are clustered near the galactic center, too faint to resolve individually with any current instrument, their combined emission could account for the signal without invoking dark matter at all. The Fermi telescope cannot distinguish the two cases directly. It sees the total excess but lacks the resolution to determine whether the emission is smooth, as dark matter annihilation would produce, or composed of many discrete faint point sources, as a hidden pulsar population would produce. As of the most recent analyses, the debate has not been resolved. Some statistical studies argue the excess has the granular texture of unresolved point sources and favor the pulsar interpretation. Others find the emission too smooth for that and favor dark matter. No independent instrument has yet been built with the capability to separate them definitively. Both interpretations require something at the core of our galaxy that we have not directly seen. What is established is that the heart of the Milky Way, the region centered on a black hole 4 million times the mass of the Sun, is radiating gamma rays in quantities that no inventory of known sources can explain, from a volume roughly 2,000 light-years across, with a symmetry that points not at any specific object but at the core itself. Whatever is producing those gamma rays has been doing so for as long as we have been capable of detecting them. It is at the center of the galaxy we live in. We have looked directly at it, and we do not know what it is. Number 8. The Amaterasu particle. On May 27, 2021, detectors spread across 125 square miles of the Utah desert registered an event that should not have been physically possible. The telescope array, a cosmic ray observatory run by an international collaboration based at the University of Utah, recorded a single particle arriving from space with an energy of 244 exa-electron volts. The most powerful particle accelerator ever built, the Large Hadron Collider at CERN, accelerates protons to energies of roughly 14 tera-electron volts per beam. The particle that hit the Utah desert carried an energy approximately 20 million times greater. It was the second highest energy particle ever recorded by any instrument in human history. The collaboration named it the Amaterasu particle, after the Japanese sun goddess, and published their analysis in the journal Science in November 2023. The problem is not merely the energy. The problem is the source. Cosmic rays this energetic are subject to a fundamental physical constraint called the Greisen-Zatsepin-Kuzmin limit. At energies above a certain threshold, a charged particle traveling through intergalactic space will collide with photons from the cosmic microwave background, lose energy in the interaction, and degrade below the limit within approximately 160 million light-years of travel. This is not a matter of instrument sensitivity. It is an inescapable consequence of the interaction between particles and the ancient background radiation that fills the entire universe. Any particle arriving above this limit must have originated within about 160 million light-years of Earth. Beyond that distance, the background radiation would have stripped it down long before it reached us. Here is the detail that keeps physicists from setting the problem aside. The telescope array collaboration traced the arrival direction of the Amaterasu particle back along its path. At this energy, magnetic fields deflect the particle only modestly, which means its arrival direction points back reasonably close to its actual source. They examined the region of sky it came from and the volume of space within the required distance. What they found there, in practical terms, was nothing. No galaxy cluster, no active galactic nucleus, no blazar, no quasar, no neutron star merger site, no candidate from any known class of object that has been demonstrated to produce particles at anything near this energy. The region the particle came from contained a large-scale void. The known mechanisms for producing ultra-high energy cosmic rays all require extreme environments, supermassive black holes with relativistic jets, the most violent shocks in cluster mergers, or the strongest magnetar flares. These are not subtle objects. They are among the brightest things in the universe. The source region of the Amaterasu particle contains none of them. The earlier Oh My God particle, detected in 1991 by a separate Utah facility with comparable energy, faced the same problem. Its source region was also largely empty. 2 particles, 2 impossible energies, 2 empty source regions, separated by 3 decades of instrument upgrades. The leading technical explanation is that the galactic magnetic field is more complex than current maps show and has deflected the particles significantly from their true origin. This is possible. It is also untestable with current field maps. The telescope array is being expanded in a project called TA×4, which will quadruple its detection area. Until that data arrives, the Amaterasu particle sits in the record books, arriving out of a void, at an energy that nothing visible in that direction should be able to produce. Number 9. Boyajian Star. In September 2015, astronomer Tabetha Boyajian at Yale University published a paper describing a single star that behaved unlike any of the more than 150,000 others the Kepler Space Telescope had watched. The star carried the catalog designation KIC 8462852. It sat about 1,400 light-years away in the constellation Cygnus, an ordinary F-type star, slightly larger and hotter than our Sun, unremarkable in every property except one. Its light did not hold steady, and it did not dim on any schedule that made sense. Kepler's entire method was to stare at stars and wait for the tiny, regular dips that a planet makes when it crosses in front of one. A large planet blocks perhaps 1% of a star's light for a few hours, on a clockwork orbit, again and again. What Kepler recorded from Boyajian's star was nothing like that. The star suffered irregular, enormous drops in brightness, some lasting days, some lasting weeks, with no period, no repetition, no rhythm at all. And the depth of the dips was staggering. At their most extreme, the star's light fell by as much as 22%. To block that much light, an object or a swarm of objects would need to cover nearly half the width of the star. Nothing in the planetary catalog comes close. A crossing planet the size of Jupiter accounts for barely 1%. This was something the scale of worlds, and it kept no calendar. The paper itself was measured and technical, but the informal name attached to the possibilities is the reason the star became famous. The leading natural explanation was a vast cloud of dust and fragmented comets, debris drifting between us and the star. But dust has a signature. Fine dust reddens the light that passes through it, scattering blue more than red, and some of the deepest early dimmings did not redden the way a simple dust cloud should. That left a stranger possibility on the table, one that a Penn State astronomer, Jason Wright, was willing to name in print. If a technological civilization were building a structure to capture a star's energy, an enormous array of collectors in orbit, the partial, irregular, deep, aperiodic dimming of its parent star is very close to what a distant telescope would record. Here is the detail that keeps the case open. In 2016, astronomer Bradley Schaefer at Louisiana State University examined a century of archival photographic plates of the same star, and reported that, on top of the sharp Kepler dips, Boyajian's star appears to have faded by several percent over the previous 100 years, a slow, steady dimming that ordinary stars of its type do not do. Later dedicated monitoring, funded in part by a public campaign that Boyajian herself led, confirmed that when the star dims, it dims unevenly across colors, which favors dust of some kind over a solid opaque object. The dust interpretation is now the leading one. It is not a settled one. No proposed cloud has fully reproduced both the century-long fade and the individual deep events at once. What remains established is that a single sun-like star, 1,400 light-years into the dark, is being crossed by something the size of planets, on no schedule anyone can predict, and slowly darkening over a human lifetime for reasons no model has closed. Whatever moves in front of that star does not keep our time. Number 10. Vasco. In 2019, astrophysicist Beatriz Villarroel at Stockholm University and the Instituto de Astrofísica de Canarias began a project with a deceptively simple premise. She took the photographic sky surveys made at the Palomar Observatory in California in the early 1950s, plates exposed decades before any modern digital instrument existed, and she compared them, point by point, against the deepest surveys of the same sky made in our own era. The idea was to ask a question no one had systematically asked before. In the roughly 70 years between the old photographs and the new ones, had anything that was clearly there simply ceased to be there? She named the effort VASCO, short for Vanishing and Appearing Sources, during a century of observations. And the answer the plates returned was not zero. There were points of light on the 1950s images, sharp and star-like, sitting in fixed positions, that do not appear on any subsequent survey. Not fainter, not shifted, gone. In her first analyses, Villarroel and her collaborators flagged roughly 100 candidates that resisted every ordinary explanation, and in a broader machine-driven search, the pool of suspicious disappearances ran into the hundreds. Each one had to be walked through a gauntlet of mundane possibilities first. Was it a defect in the old photographic emulsion, a fleck of dust, a plate flaw? Was it an asteroid caught mid-crawl, a variable star at the peak of a flare, a distant object that had simply dimmed below the limit of detection? Most candidates fell to one of these, some did not. Here is the detail that astronomers find uncomfortable to sit with. A star does not simply turn off. Stellar physics does not contain a mechanism for a sun-like point of light to be present, luminous, and catalogued, and then to be absent, with nothing left in its place. The gentlest end a star can meet is a slow fade across billions of years. The violent ends are violent precisely because they are bright. A supernova that outshines its galaxy, visible across the observable universe. There is a theorized quiet death, the direct collapse of a massive star straight into a black hole without the explosion, a star that fails and winks out. It has been tentatively observed perhaps once. It is not supposed to be common. It is certainly not supposed to account for 100 lights going dark in 70 years across a small patch of surveyed sky. Villarroel has been careful, publicly and repeatedly, to say what the science can and cannot support. The disappearances are real in the sense that the sources are genuinely on the old plates and genuinely absent now. What produced them is unknown. She has noted, with the caution of someone who understands how the claim will be read, that any survey of vanishing lights is also, by definition, a search for signs of technology, because a deliberate signal or a deliberate extinction would look exactly like an anomaly that no natural process explains. She has not claimed that is the answer. She has said, correctly, that it cannot yet be ruled out, and so the plates sit in their archives, 70 years old, showing lights that were there when the photographs were taken and are not there now. Something in the dark closed the distance between those two exposures. We did not see it happen. We only noticed, decades later, by laying one photograph over another and finding the holes. Set that beside everything on this list. A supermassive black hole at the center of our own galaxy that erupted with the power of hundreds of millions of supernovae 3.5 million years ago, then went silent, something pulling hundreds of galaxy clusters toward a point outside the entire observable universe. A cold scar pressed into the oldest light in existence. Something at the galactic core, radiating gamma rays in quantities no known source in that region can account for. A star crossed by world-sized objects on no schedule we can read. A particle arriving from an empty void at an energy 20 million times beyond what our most powerful machine can produce. A sky twice as bright as every star and galaxy ever catalogued, the excess belonging to nothing we can name. Worlds without suns drifting in their billions, each one a sealed dark ocean where evolution had billions of years to work in permanent darkness. And now, lights going out, one by one, in photographs taken before anyone thought to look. None of these is proof of anything. Every one of them has a mundane explanation still in contention. But not one has been closed, and together they describe a dark that is not empty, only very, very quiet. We have sent probes past the edge of the solar system, imaged black holes 55 million light-years away, and built detectors that feel the gravity of two colliding stars a billion light-years from here. And still we do not know what switched those lights off. If you want to keep looking into the dark with us, subscribe and turn on the notification bell so you don't miss what's next. Leave a like if this one kept you up, and tell us in the comments where in the world you're watching from tonight.